Far from any planet, a small scientific spacecraft drifts through deep interplanetary space. Ahead shines the sun, no longer a distant star but a slowly growing sphere of light. The vessel is on a one-way research mission to fall toward the sun and transmit data for as long as its systems remain operational. Inside the cockpit, instrument panels glow softly in blue and amber tones. Through the forward observation window, the sun appears calm and almost peaceful, but the ship's sensors already detect the solar wind, streams of charged particles racing outward through space at enormous speeds. Small maneuvering thrusters fire briefly along the sides of the spacecraft. The vessel slowly rotates, so its massive heat shield faces directly toward the star. Without that shield, the spacecraft would survive only seconds once the radiation becomes intense. Golden sunlight spreads across the metallic hull. Long antenna structures cast thin shadows across the surface, while the sun slowly expands in the darkness ahead. As the descent continues, the star begins revealing motion across its surface. What once looked like a smooth, glowing disk now shows enormous, swirling textures. These are convection cells where superheated plasma rises and sinks in endless circulation. Inside the ship, scientific displays fill with new data. Temperature readings rise slowly. Radiation counters tick faster every minute. Though still millions of kilometers away, the sun already dominates the surrounding environment. Large protective plates unfold across the front of the spacecraft like metallic petals. When they lock into place, the vessel resembles a small armored insect pointing directly toward a giant furnace. Sensors visualize the solar wind surrounding the ship. Invisible particles appear on monitors as glowing streams flowing past the hull like cosmic rain. A small scientific probe separates from the spacecraft and drifts beside it. Its task is to measure radiation, magnetic fields, and particle density as both machines fall deeper toward the star. Ahead, the sun grows brighter and wider in the window. The descent has truly begun. Now the sun dominates a large portion of the sky. Automatic filters darken the camera image to protect sensitive instruments from the overwhelming brightness. The star's surface is no longer smooth. It moves constantly like a slow ocean of fire. Outside the spacecraft, the heat shield begins glowing faint orange. It absorbs tremendous energy and radiates it back into space. Thousands of microscopic sensors measure every change across its layered ceramic surface. Inside the cockpit, cooling pumps activate with a low mechanical hum. Liquid coolant flows through thick pipes embedded in the hull, carrying heat away from critical systems and delicate electronics. The nearby probe sends back its first detailed measurements. Solar wind particles stream outward at hundreds of kilometers per second, forming invisible storms that stretch across the solar system. Ahead, the sun's corona becomes visible. It spreads outward like ghostly white flames shaped by the star's powerful magnetic fields. Long, luminous structures extend millions of kilometers into space. The spacecraft glides deeper into this region. Cameras capture enormous magnetic loops, rivers of plasma arching through space like glowing bridges suspended above the star. Suddenly, a powerful solar flare erupts across the surface below. A brilliant arc of plasma rises thousands of kilometers before slowly collapsing back toward the sun. Inside the ship, radiation meters respond instantly. Numbers jump sharply as high-energy particles rush outward from the eruption. The spacecraft automatically adjusts its orientation, ensuring the thick heat shield remains pointed toward the star and the incoming radiation. Outside the hull, glowing particle waves rush past like cosmic dust carried by a violent wind. The sun now fills most of the forward view. At this distance, the sun becomes something entirely different from the quiet star seen from Earth. Its surface appears alive, covered with bright, granular patterns. Each glowing bubble is larger than entire countries on our planet. Outside the spacecraft, the heat shield glows a deeper orange. Streams of energetic particles strike it constantly, producing tiny flashes like sparks inside a giant forge. Inside the cockpit, warning lights begin to pulse softly. Radiation levels approach the upper limits of the ship's protective systems. The probe, drifting slightly ahead, sends dramatic images back to the main vessel. Towering structures of plasma rise above the surface, solar prominences twisting upward like flaming tornadoes. Some of these immense arcs stretch tens of thousands of kilometers high before slowly collapsing under gravity and magnetic forces. Suddenly, the probe's signal weakens. A surge of radiation floods its instruments, overwhelming several sensors. For a moment, the video feed dissolves into static. Then the transmission disappears completely. The probe has been destroyed by the intense solar environment. Back on the main spacecraft, cooling systems accelerate to maximum capacity. Pumps force coolant through the hull faster than ever before, while external temperatures continue rising. The corona now surrounds the spacecraft entirely. Pale streams of plasma drift past like glowing clouds shaped by violent magnetic storms. Another solar flare erupts far below. A brilliant loop of plasma launches upward before breaking apart into streams of blazing particles. Radiation alarms sound briefly as the expanding particle wave reaches the ship. Outside cameras show the heat shield glowing almost red beneath the relentless bombardment of solar energy. Layers of ceramic protection slowly radiate the incoming heat back into space, allowing the spacecraft to survive just a little longer. Below, the sun's surface churns violently, an endless ocean of incandescent plasma, rising and collapsing in massive convection cells. Bright regions surge upward, while darker lanes sink back into the star. Magnetic field sensors display complex patterns across the cockpit screens. Invisible forces twist the solar plasma into enormous loops and spirals that stretch thousands of kilometers above the surface. The spacecraft moves through one of these magnetic regions. Streams of glowing particles curve around the vessel like luminous rivers following invisible pathways. Outside, enormous arches of plasma, solar prominences, rise like flaming mountains. Some slowly collapse, sending waves of charged particles rushing outward through space. Inside the cockpit, vibration sensors detect faint shaking as turbulence in the solar atmosphere pushes against the hull. The spacecraft remains stable, but the forces outside grow stronger every minute. Now the sun fills the entire sky. There is no darkness ahead, only endless fields of blazing plasma stretching in every direction. Cooling systems run at full power while data continues streaming back toward distant Earth. Below the spacecraft, the sun's visible surface, the photosphere, moves like boiling liquid fire. Giant granules expand and collapse in slow, powerful motion. The ship descends closer, hovering only a few thousand kilometers above the blazing layer. For the first time in history, a human-built machine has reached this close to the star. Every sensor records the environment in extraordinary detail. Temperature, magnetic fields, radiation storms, and plasma flows. The spacecraft continues its slow fall toward the sun. The light becomes blinding, the heat grows overwhelming, and the mission approaches its final moments as the ship moves deeper into the living atmosphere of our star.